All right, continuing our work with triangles. Section 3 is going to add a couple theorems that we have with triangles, and it will involve their angles, some interior, some exterior. But we're going to start by proving one of these theorems. And what we have to start is we have a side of the triangle that is parallel to another line that's intersecting the angle opposite that side. So that would be AD being parallel to CB. Okay. Hopefully we can use some of our angle relationships formed by lines intersecting parallel lines, and we can see that 1 and 4 are alternate interior angles, therefore they are congruent. And then there's another pair of alternate interior angles that are congruent on the other side, 5 and 2. And then we're going to combine two statements here really into one. The linear pair theorem states that two angles that are adjacent and form a straight line are supplementary. We're going to combine that with angle addition postulate and state that three of these angles that are adjacent and form a straight line add up to 180. We're just going to say our linear pair theorem combined with our angle addition postulate. We're going to skip the step where you would substitute the two angles in using the linear pair theorem. Finally, if 5 is congruent to 2, then we can substitute 2 in for 5. If 1 is congruent to 4, we can substitute 1 in for 4, and now we have 1 plus 3 plus 2 equals 180 degrees. Those are the three interior angles of a triangle, which means the three interior angles of a triangle will always sum to 180 degrees. We just use substitution here. And now we'll go state that theorem. The triangle sum theorem states the sum of the angle measures of a triangle equals 180 degrees. And you can see that right here in our diagram. A plus B plus C equals 180. Okay, let's go ahead and use that in this example where we're finding the measure of a given angle. For A, you're asked to find the measure of X, Y, Z. That would be this angle right here. Hopefully you can see we have two of the three angles in this triangle. So if we add those two angles and subtract them from 180, we are left with the measure of angle XYZ, 78 degrees. All right, why don't you try B? We're looking for the measure of angle YWZ. That would be this angle in the corner. And you're probably going to want to find the measure of this angle first using the linear pair theorem. Use the angle that's adjacent to X to find that angle, and then you can find the measure of angle W. All right, go ahead. You needed to subtract 62 from 180 because these are adjacent and form a straight line. That angle would be 118. And now we have two of the three angles in this triangle, and we could subtract them from 180. 112 plus 18 is 130, and we're left with 50 degrees. Right. Moving on, there's two, and we call these corollaries, that are really, they're just theorems. There's two theorems that come from our triangle sum theorem. They follow directly from that theorem. The first one states that if you have a 90-degree angle, therefore a right triangle, then the two other angles in this triangle must be complementary because 90 plus 90 equals 180. So if you know that you have a right triangle, we know that those other two acute angles have to sum to 90. the acute angles of a right triangle are complementary. Okay, we have a second corollary, which involves the three angles of an equiangular triangle. Remember, an equiangular triangle is a triangle with three congruent angles. Well, if we know that the three angles of a triangle sum to 180, then we know that each of those angles has to equal 60 degrees, because 60 times 3, or 60 plus 60 plus 60 equals 180. So the measure of each angle in an equiangular triangle is 60 degrees. All right, let's use what we know from these two corollaries, which come directly from our triangle sum theorem, to solve. Let's just do A in this example. We won't worry about B right now. A states the measure of angle 1 in an acute triangle is 62 degrees. The measure of one acute angle in a right triangle is 62 degrees. What's the measure of the other angle? Well, if it's a right triangle, you know one angle is 90, so we know that 60 plus some other angle needs to equal 90 degrees. That would be 90 minus 62, which gets us 28 degrees. Okay, 28 plus 62 plus 90 equals your 180. The set of points inside the figure, that's called the interior of the triangle, or interior angles. The exterior would be the set of points that are located outside the figure. An interior angle, which were those three angles that form, or that sum to 180 degrees, they're formed when the two sides of a triangle meet. An exterior angle is when we extend one of those sides. So as you can see right here, we extend the base of this triangle, and now we have this exterior angle of 4, okay? The reason we're defining those is we have an exterior angle theorem as well, just like we have an interior angle theorem, okay? And we're gonna prove that here. I'm gonna show you this GeoGebra link in class that proves the exterior angle theorem, but we're gonna start with this interior angle theorem, that 1 plus 2 plus 3 equals 180 degrees. Triangle sum theorem. One we just proved and we're using on the previous page. We also have a linear pair, 3 and 4, so we can state that the measure of 3 plus the measure of 4 equals 180 degrees. Linear pair theorem. Okay, and now if we have two sets of equations equaling 180, we can substitute and set these two angle measures equal. They both equal 180, so we can set them equal to each other, substitution. And then we are left with, if we want to just subtract the measure of angle 3 from both sides, we're left with 1 plus 2 equals 4. Subtraction property of equality. And then go ahead and take a look. I'm going to erase these circles on here. Where 1 and 2 are located, and then where angle 4 is located. 1 and 2 are inside, 4 is outside. So this angle in the exterior will always equal the sum of the two non-adjacent interior angles. That's our exterior angle theorem that we're going to define on this next page. We're going to use a little bit more vocabulary here that we'll define in just a sec. the measure of an exterior angle of a triangle is equal to the sum of the measures of its two non-adjacent angles. Okay. So you can see that right here. The measure of angle BCD, located in the exterior, this angle right here, equals the measure of angle A plus the measure of angle B. Okay. We're going to use that down here in these two examples to solve for a variable and plug it in to find whatever angle you're asked to here. So we're asked to find angle B. This 5x minus 60, that's our exterior angle. So our equation should be 5x minus 60 equals these two non-adjacent angles, 15 plus 2x plus 3. We're going to solve for x. Let's get our variables on the same side. We can combine our like terms here. Add our 60 to the other side, and we get 3x equals 78. And that's going to go in evenly. We get 26. If we want the measure of angle B, we need to plug our 26 in. 2 times 26 plus 3 gets us 55 degrees. All right, let's finish up with, we'll let you go ahead and try example B on your own. Try example B, and then we will see what you get. Okay, hopefully your equation looked like this. 6z minus 9 equals the two remote interior angles added together, which would have been 90, or sorry, remote is another word for non-adjacent. Should make note of that up here. You would have solved for z and gotten 25. When we plug z back in for angle ACD, that was the exterior angle, you would get 141 degrees. All right, let's finish with our last theorem here, our third angles theorem. The third angles theorem just states if you have two pairs of congruent angles in two triangles, then the third angles must be congruent. So let's state that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And that's what we have here. D and A are congruent, B and E are congruent, therefore we can say angle C has to be congruent to angle F. Think about it if we were using the sum of the interior angles theorem. If this was, say, 60, and this was 60, and A was 50, and D was 50, well, these two angles have to equal the same measure in order for these two angles to be congruent, right? Okay. Let's use that here for example. We'll do example B together. Two pairs of congruent angles in each triangle. That means this last pair of angles must be congruent. So we're going to set them equal to each other. 2x squared equals 4x squared minus 32. Let's subtract our 4x squared from both sides. We get negative 32 equals negative 2x squared. Divide by our negative 2. X squared equals 16, and when we take the square root of 16, we get x equals 4. 4 times 4 gets us 16. And then just plug it in to find the measure of both. And we'll just plug it into one of them. It's going to be the same measure on both. We get 2 times 4 squared, which is 2 times 16. So we are left with 32 degrees. Okay, why don't you try A, knowing that F is congruent to I and G is congruent to H. Those third angles must also be congruent. Go ahead and set up your equation and solve for Y. Should have had 4y equals 6y minus 40, which gets you y equals 20. Plug 20 in for, you can just do it for one of these angles. You get 4 times 20, which is 80 degrees for both of these angles. Okay, great job. 3 theorems that we threw at you today: third angles theorem, exterior angles theorem, and the triangle sum theorem. 3 angles of a triangle always sum to 180 degrees. You'll be using those on the homework, and we'll be practicing these in class.